the Milky Way's fastest stars might be stolen. New research suggests hypervelocity stars are runaways from another galaxy. In 2005, astronomers discovered a star unlike any other in the Milky Way. Most of the billions of stars in the galaxy, including our Sun, travel at an average speed of about 800,000 kilometers, or 500,000 miles, per hour. But this star? It was moving 3 times faster than that, hurtling across space at 2.5 million kilometers, or 1.6 million miles, per hour. Since then, astronomers have discovered about 20 of these fast-moving stars, known as hypervelocity stars. They've also been trying to pin down their origin. The leading theory comes from a 1988 paper that predicted the existence of hypervelocity stars, years before the first one was observed. It suggests a hypervelocity star starts out as one half of a binary star system that gets too close to the supermassive black hole at the Milky Way's center. The black hole captures one star, pulling it into a tight orbit, and pushes away the other, slingshotting it across the galaxy at enormous speeds. But Douglas Boebert, a Ph.D. student at the Institute of Astronomy at Cambridge, isn't sold on this theory. It became the best explanation because it was the only explanation for these stars, Boebert says. Boebert and his colleagues offer another explanation, published Tuesday in the monthly notices of the Royal Astronomy Society, based on telescope observations and computer simulations. The Milky Way's hypervelocity stars, he says, don't originate in the Milky Way at all. They are, instead, runaways from a smaller galaxy orbiting our own called the Large Magellanic Cloud. Each hypervelocity star was part of a binary system in this dwarf galaxy until its twin exploded. The force of the supernova ejected the surviving star at such great speeds that it was able to escape the gravitational pull of the dwarf galaxy and eventually find a new home in ours. Astronomers have previously observed this process, the breaking apart of binary systems because of supernovae, in the Milky Way, but it has not produced the kind of hypervelocity stars that travel millions of kilometers per hour. This origin story is less extreme, Boebert says. You're not talking about the black hole in the center of the Milky Way, the biggest object in our galaxy, and having it catapulting stars off at thousands of kilometers per second, he said. You're talking about a process which is well documented, which is guaranteed to be happening, and just putting it in a different galaxy. Boebert says it helps explain these hypervelocities' position in the sky. The majority of the 20 known hypervelocity stars are clumped together in 2 constellations, Leo and Sextans. The black hole theory can't explain why we only see the stars in one part of the sky, because you'd expect that particular mechanism, if it's in the center of the Milky Way, to eject in all directions equally, he says. Boebert came to his theory in April last year, when he was reading a research paper that mentioned that the Large Magellanic Cloud orbits around the Milky Way at 400 kilometers per second, or about 1.4 million kilometers per hour. I put 2 and 2 together and realized that if you could eject a star from this dwarf galaxy, it would be very, very fast, he says. The star, already moving at a high velocity because the supernova kicked it out, would get another boost from the fast-moving galaxy. Imagine putting a star into a cannon, and then putting the cannon onto a moving train, Boebert says. Boebert and his colleagues used data from the Sloan Digital Sky Survey, which has observed millions of cosmic objects in more than 1/3 of the night sky. They took what they knew, like the rate of star formation in the Large Magellanic Cloud and the prevalence of binary star systems, and input the information into computer models that simulated the evolution of the cloud over 2 billion years. The simulations showed how many binary systems might undergo supernovae and eject runaway stars that could then end up in the Milky Way. Boebert says his research predicts there may be many more runaway, hypervelocity stars in the Milky Way, as many as 10,000, hiding out of view of telescopes. The stars are traveling so fast that they will likely escape again in a few hundred million years and perhaps, someday, become part of another galaxy. Like their twins, hypervelocity stars may explode too, leaving behind dense cores, called neutron stars or matter-gobbling black holes. Some runaways that left the Large Magellanic Cloud as stars may have arrived inside the Milky Way galaxy as neutron stars or black holes. Boebert suspects this theory will be met with some skepticism after a decade of research based on the leading assumption. He hopes that the European Space Agency's Gaia mission will provide more data to work with when it releases its first observations next year. The spacecraft, launched in 2013, is monitoring and measuring the position and velocities of about 1 billion stars in the Milky Way. Until then, hypervelocity stars are a good reminder of the extremes found in the universe. The fastest thing you typically see in a day is a car, and that's traveling at 70 kilometers an hour. Boebert says that's tiny in terms of the vastness and the scale of things that are happening in the sky.